Ladies and gentlemen, it's Mr. Green. It's time for our Class Connect time with AP Statistics, and the Class Connect's not in the list. It's disappeared. It's not there. And Mr. Green's nowhere to be found. I tried contacting him. He's not there. Hopefully you remember I'm giving tax tests today. I'm thrilled about it too. I can't be in Class Connect and give tax tests. They just don't let us do that sort of stuff. So what I did is I'm recording this a little bit in advance so that you can get a Class Connect today. Nice, a little abbreviated, but it'll be a good Class Connect, okay? Where should you be? You should be working on the things that'll get you completed with Unit 8. We are looking at two independent samples this time. So we're going to be looking at two independent samples. We are getting near the end of Unit 8. So be aware, it is getting close. Okay? We are doing these are the things that are in the AP statistics list that we should be doing. And that's what we're doing right now. We're doing T samples and two sample T procedures and things like that. So that's what we're doing. Okay? Speaking of the AP test, I've only heard from two people who have set up to take the AP test. I mean, there's several more of you. I mean, you should be out there trying to following the directions that are in the announcements and getting back to me by the 8th about where you're going to be taking that test because I really need to know. Okay? Because I can't see your grades unless you tell me where you're going to be taking the test at. So I would love to see them. I'd love to know how you do. So please let me know where you're going to be taking the test. I'm not the only one who wants to know. There's a couple of other high ranking people who are going to be after you trying to get it too. So please get back in touch with me, tell you where you're going to be taking the AP test. Okay, suppose we compare the data on two samples, a sample A and a sample B, and we come up with the following information. The sample sizes are the same, but the x bar is 20, x bar A is 25, and the standard error A is 3.21, the x bar B is 22.2, and the s bar B is 3.09. And it's asking what's the standard error, the difference between these means. This is something I really didn't cover, but there are equations that are on almost every test. And what I used for this one was a simple little thing. It says that the S is equal to the standard deviation of 1. Let's see here. Standard deviation of one of the samples squared divided by n plus the standard deviation of the other one, 2 squared divided by n, and take the square root of the whole thing. So can we do that real quickly? Why, sure we can. So if we come along, we say 3.21 squared divided by 10 plus 3.09 squared divided by 10. I'm going to take the square root of the whole thing. I get 1.41. Okay? I know this wasn't two independent samples that we were doing this. This was just two samples that looked like they could have been paired with each other because they're the same size. But it does work. Even on the independent samples, you could do this, okay? And it'll give you the standard error. That's something you need to know. It's a difference in means that you're looking at there. Okay, a couple more questions. We draw two independent samples from two distinct normally distributed populations. The means and the standard deviations of the populations are unknown, but we're interested in comparing the two populations to see if the means are the same. What could we use to get this information? You know what? Handy dandy calculator. If you press stat and you go over here to test, there is a two population t-test right there, number 4. Number 4 right there. Not there, there. We could use that information, right, and use that to help us get to the right answer. And so a two sample t confidence interval is what they're saying here. Oh, confidence interval. I didn't see them say they wanted a confidence interval. Oh, well, they're wanting to compare the two against them, so maybe they do want a confidence interval there. What could we use in that situation? Instead of this t-test, we can go on down here to number 0, and that is the two sample t interval. Cool. So we can use that information to get a t-interval or a t-test either way. Okay? So let's try a couple of things here. A store manager wants to know if there is a difference in between packing containers for eggs. One type of container holds 30 cartons of eggs. The cartons are shipped in these containers contain an average of X bar. X bar. Okay? 75 broken eggs with a standard deviation S1. Okay? Of one tenth. A second type of container contains 32 cartons with a average broken number of eggs of X bar 2 and S bar 2. S2. The two sample t statistics would you use to conduct a hypothesis test in this situation? Well, in this situation, what I would use would be that two sample test, okay? Because we want to get the t statistic, okay? So what I'm going to do is I'm going to put a little trick here. I'm going to say that's N1 and that's N2. Why am I saying those are the N's? Because if we just look at one sample of it, one carton of it, this is going to be the mean, this is going to be the standard deviation, and so we could use that information. So let's come back here to this, and we're going to go back up here and do a number 6. 2 population, not Z test, number 4, T test. Okay? So I'm going to press enter on this. I'm going to go over to statistics. Even though these are different numbers, I'm going to go to statistics. And my X bar in this situation is going to be 0.75. My S is going to be 0.1. And my N in this situation was 30. Those were the 1 numbers. My 2 numbers here was a 0.6. Couldn't remember it. 0.6. And my standard error was 0.12. And my N in this situation was no, why'd you do that? Oh. Okay, 0.12. And my N in this situation is 32. It gave me an error there. That wasn't what I was expecting. Okay? Okay, now the question is, what will we use to test this situation? What kind of a test are we doing? We're trying to see if one container has more broken eggs than the other one. Right? So would we do a equal, less than, or you know what? I think I would do an equal because we want to see if they're equal to each other. If they're difference in this situation, and that's what I'm thinking that I'd be doing. And so I'd be going down here, and it's not pooling. We're not pooling the data. We're going to calculate it, and we get a value for the t statistic, which is what we're looking for right here, 5.36. Okay, and so we check, and that is what we got, 5.36. Woohoo! Everyone see where I got that right there on the calculator, 5.36. Cool. Okay, move forward here and look at another one. Here, suppose biologists have been studying the question of whether squirrels produce more offspring in colder climates. Huh? Well, the theory goes like this. The colder climates, fewer offsprings will live to maturity, so the squirrels need to produce more offspring to make the additional loss of make up for the additional loss of life. So, in a study on a species, scientists collected data on the number of offsprings of squirrels in both states between California and Oregon. Okay? And here's the information right here. And by the way, this is all hypothetical. It's all made up data. So don't worry about it. I mean, we didn't go count number of squirrel babies or anything like that. Okay, so there's our data. And what they're actually testing here is interesting. They're saying that it should be more in Oregon than in California. So this isn't a two-sided test. This is a one-sided test that we have to be careful with here. Okay? And they're wanting the p-value, so basically we're going to do the same test again, right? And so we're going to go into stat, we're going to go over to test, we're going to do number 4. Okay? It's going to be statistics, and our x bar in this situation is going to be 11.49. You can see where I'm getting that from. 11.49. Our S in this situation is, sorry, I don't have it on the screen there, 4.28. 4.28. And our N in this situation is 73. Yeah. Our X bar in this situation for number 2 here is 13.57. 13.57. Our S bar is 3.71. 0.71. And our N in this situation was not the same value. It was 49. 49. Couldn't find as many of those squirrels around. And we're looking for a one-sided test. Do we want, they're thinking that U2 is going to be greater. The mean of the second one should be greater. Right? Well, let's look. Does it look like it's greater? It is. So, I mean, that's what they're testing for. They're testing to see if it is greater. So let's go down here and do a not pooled data and calculate our information. And our p-value that we get is 0.002. I didn't see the next digit. 6. Do you see how I got that value? All right. Let's see if that's what they gave me as a number. That is what they gave me as a number. I didn't put the screen up there. 0.0026. So that's what we are looking at. Now, these two sample statistics, either the one here at number 4, stat test, the one here at number 4, two sample t statistic, or going on down here a little bit lower and doing the interval, the two sample interval, it works for several different things, okay? It doesn't matter if the sample sizes are the same. It's one of those things where if they're independent sample sizes and you can say they're independent and you can see a normality, then you're going to be pretty well easily using those that information. And you can just abbreviate two sample t interval, two sample t test. Okay? Okay, well, that's going to be the class Connect for today. Secret word for today is dangerous. Since none of you can be live in my class, if you're watching this recording, I want you to send me that word, dangerous. And that's what I'll be using to see that you watch this class. I don't know, something about armed and dangerous. We went to eat at Chipotle's today. We'll go from there. Okay? So, I look forward to seeing you next time we get together. And I appreciate the fact that you guys do tell me that you're in AP Statistics when you send me information. Send me that secret word so I can say that you were here. I'll talk to you later.